In this lesson, we're going to talk about three-dimensional figures. Three-dimensional figures are called polyhedron, right? A polyhedron is a solid with all flat surfaces that encloses a single region of space. Now, some of the things that have to be true of polyhedron, remember the two-dimensional figures are called polygons, all right? And a polygon is on a plane, okay? The polygon is on a plane because it's two-dimensional. A polyhedron takes up a region of space. So it takes not only length and width, but it also takes up height. Now there's several different parts of a polyhedron. You have the flat surfaces of a polyhedron, which are called faces. You have edges, which is the line segment that's formed where the faces meet. And then you have vertex. The vertex are vertices, which a vertex is the point or the corner where three or more edges meet. Go ahead and pause the video for a minute and copy this information into your notes. Right. So there are two primary types of solids. You have a prism. You have a prism, which is a polyhedron that has two parallel faces that are called the bases, connected by parallelogram faces. All right. So, and parallelograms have two sets of parallel sides. Okay. So you have the top and the bottom that are parallel, and the right side and the left side that are parallel. Okay, so that's called a prism. A pyramid is a polyhedron that has a polygon base and then three or more triangular faces that meet all the way up here at the top. That's called a vertex. And depending on the shape of the base depends on how many triangular faces that you have. If you have a triangular base, then you're going to have three triangular faces. If you have four, like in this case, you're going to have four triangular faces. If you have a pentagon for a base, you would have five. All right. Polyhedrons are named by the shapes of their bases, which I just referred to. Okay, so when you're talking about prisms, the prisms that have triangles as their bases, like in this case, are called triangular prisms. Okay, and you notice that the bases do not have to be on the bottom. The bases are just simply the two parallel faces. All right, the faces that are parallel. So if you have triangles, that's a triangular prism. If you have rectangles, you have a rectangular prism. And if you have pentagons, you have a pentagonal prism. Remember, a pentagon is a polygon with five sides, right? When you're talking about pyramids, you have a triangular pyramid. You have a rectangular pyramid that has, the triangular pyramid has a triangle as a base and then three triangular sides. A rectangular pyramid has a rectangle or a square for a base and four triangular sides. And then a pentagonal pyramid, which has a pentagon as a base and five triangular faces. So pause this video This is a lot of information. Go ahead and copy this information into your notes. There are some other three-dimensional figures or solids that are not polyhedrons. Remember, polyhedrons have straight sides. All right. A cylinder is a three-dimensional solid that is not a polyhedron because the bases are circles. Okay, and circles don't have straight sides. All right. You have cones, which the base again is a circle, and so it doesn't have straight sides. And then you have a sphere, which is a ball. So each of these solids here, all three of these solids here, have faces that are not flat, as well as having a circular base for the cylinder and the cone. So pause the video and copy this information into your notes as well. All right, a polyhedron. The polyhedron is a regular polyhedron if all the faces are regular congruent polygons. In other words, remember, regular polygons means they have the congruent side lengths. So we have congruent side length and congruent angles, or congruent angles. All the angles are congruent. Okay, so a polyhedron is a regular polyhedron if all the faces are regular congruent polygons and all the edges are congruent. All the edges of the polyhedron are congruent. These are called Platonic solids, which are actually named after Plato because he did a lot of work with these. And there are basically five primary types. You have a tetrahedron, which has 4 equilateral triangular faces. You have a hexahedron, which we commonly refer to as a cube, which has 6 square faces. You have an octahedron, which has 8 equilateral triangular faces. We have a dodecahedron, which has 12 regular pentagonal faces. And we have a icosahedron, which has 20 equilateral triangular faces. Pause the video and copy this information into your notes as well. All right, so some examples. Name the solid. Well, this is a prism. All right, so it's a prism. And determine whether it's a polyhedron. Well, all the sides are straight. All right, and you have flat surfaces. All right, the bases are rectangles, so this is a rectangular prism. So it's a rectangular prism. All right, so if it's a polyhedron, how many faces does it have? Well, you have the front, it's front here, you have the back, you have the top, you have the bottom, so that's 4, and you have the left side. Let me get a different color. Left side, which is this over here, and you have the right side. So that would be 1, 2, 3, 4, 5, 6. So there are 6 faces. How many edges does it have? Well, let's see. Let me get a different color. We have 1, 2, 3, 4. 4 edges along the top. Same 4 edges along the bottom, so that's 8. And then you have 4 edges that connect the top and the bottom. So that means that it has 12 faces, right? 12 edges. So it has 6 faces, 12 edges. All right. And how many vertices does it have? Well, it has 1, 2, 3, 4, 5, 6, 7, 8. So it has 8 vertices. All right. Name this solid. Well, you can see that it is a prism because it has opposing sides, which are called faces. So it is a prism. And the sides are all the same, are all straight. All right. So it has 1, 2, 3, 4, 5. The faces is a 5-sided figure, which is a pentagon. So this is a pentagonal prism. All right. How many faces does it have? Well, it has the top and the bottom, which is 2. Then it has this face, this face, this face, this face, and this face. So it has 1, 2, 3, 4, 5. It has 5 faces connecting the top and the bottom, plus it has the top and the bottom. So it has 7 faces. There's 7 faces. How many edges does it have? Well, obviously there's 5 along the top. 1, 2, 3, 4, 5. There's 5 on the top, and because the bottom is the exact same shape, it has 5 on the bottom. All right, so that's 10. And then it has 5 edges that connect the top and the bottom. So that would be 2, 3, 4, 5. So that would be 15 edges. All right. And then it asks how many vertices it has. And we can see 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So it has 10 vertices. All right. The next solid. Well, this solid is a cone. That's a cone, and because it has a circular base and a curved side, it is not a polyhedron. Or I'm sorry, yeah, polyhedron. It is not a polyhedron. And because it's not a polyhedron, it doesn't have any faces and edges or vertices that we we don't count the face as it doesn't have a polygon face, okay, because the face is a circle, and I guess we would have a vertex where that is, but a vertex really is formed when polyhedrons meet, or when polygons meet, and because the edge of a cone is not a polygon, it really is not necessarily considered a vertex, right? All right. The next subject we're going to talk about are surface areas and volumes. Okay, the surface area is just simply the two-dimensional measure of the surfaces of a solid figure, and it can be found by adding the area of each of the faces and adding them all together. A lot of times we use maps, the figure maps, in order to find surface area. All right, and we're going to be doing some activities using polyhedron mapping. Right, the volume is a measurement of the amount of space that's enclosed by a solid figure. So go ahead and copy these two definitions into your notes. After you've copied that into your notes, then we have a bunch of formulas that we have to use on a regular basis in order to find surface area and volume. And I will, rather than making you guys copy all these into your notes, you can. Would be a good idea to copy these into your notes. But I will also bring sheets that you can put into your notebooks that will have this information on it. Right. So surface area, you can tell that if we're doing a surface area, we have a rectangle on top, we have a rectangle on the bottom. We know to find the area of a rectangle, just simply taking the length times the width. So we can take the length times the width of the top, length of the times the width of the bottom, length times the width of the right side, length times the width of the left side, length times the width of the front, and the length times the width of the back. And that's a lot of work and a lot of multiplying to do that. This formula that we're given down here to find the surface area of a rectangular prism is just say take the perimeter of the base times the height, plus you find the area of the base and multiply it times 2. That'll give you the surface area of a rectangular prism. All right. Same thing goes with a regular pyramid. You take half of the perimeter of the base times the slant height. Remember, and the slant height is not the height of the pyramid, but the height of the triangular face. Okay. Plus, you take the area of the base. You add the area of the base to that. Okay. So basically, you're finding the area of one of the triangular sides times the perimeter, and then adding that to the area of the base. Cylinder, surface area of a cylinder. A cylinder, if you think about it, has a circle on top, a circle on the bottom, and then the side is made up of a rectangle that the width is the same thing as the height, and the length is the same as the circumference of a circle, which the circumference is 2 times the radius times pi. Right? Cone is 3.14 times, or pi times the radius times the slant height plus plus the area of a circle, and the surface area of the sphere is 4 times the area of the circle that makes up the sphere. Or 3, well, not quite actually, because it doesn't take it times, yeah, it does. 3.14 times the area, 3.14 times the radius squared, which is the area of the circle that makes up the sphere. Volume, you've seen the volume of a lot of these, and I'm not going to read over every single one. We're going to do several examples. I don't want this video to get too long. Okay, here it says find the surface area and volume of this rectangular prism. Okay, so if you remember the formula to find the surface area of this is to find the perimeter of the base. So the perimeter of the base times the height plus 2 times the area of the base, which is length times width. All right. The perimeter is 5 plus 4, or 2. Remember, perimeter is 2 times the length plus 2 times the width, all right, times the height plus 2 times length times width, all right? So 2 times the length would be 2 times 5 plus 2 times the width, which is 4, times the height plus 2 times the length, 5, times the width, 4. Okay? Continuing our math, 2 times 5 is 10, 2 times 4 is 8, times the height, which is 6, plus 2 times 20, this should be in parentheses here, because we're going to add that first. So that's 18 times 6 plus 40. 18 times 6 is 108. So when we combine this, we end up with a surface area of 148. Okay, the volume I'm going to do the volume over here. Volume is length times width times height, right? So the length is 5 times 4 times 6. Right, so basically what we're doing here is we're just finding, anytime we're finding volume of a prism or something like this or a cylinder, you're finding the area of the base and then multiplying it times the height. That's the easiest way to think about it. So 5 times 4 is 20 times 6. 20 times 6 is 120. Okay, and remember this is 5 feet, 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 so that would be 120 cubic feet. This would be 148. This is all feet squared, so 148 square feet. Right? Find the surface area and the volume of the cylinder. To find the surface area of a cylinder, it's 2 times 3.14 times the radius times the height plus 2 times 3.14 times the radius squared. or this is the area of the base. Okay. That's the area of the base. All right. So plugging in the numbers, we're going to say 2 times 3.14 times the radius, which is 3, times the height, which is 8, plus 2 times 3.14 times the radius squared, 3 squared. And then we just do the math. We go 2 times 3.14 times 3 times 8, which is 150.72 centimeters squared, plus 2 times 3.14 times 9, 3 squared is 9, which is 56.52 centimeters squared. And so we add those two together. And we end up with this whole mess here comes up with 207.24 square centimeters. All right? So that's the surface area. That's the surface area. Volume is the area of the base, which is 3.14 times the radius squared, and then we're going to take that times the height. All right, so remember, so that's 3.14 times 3 squared times the height, which is 8. 3 squared is 9. Times 8. Use our calculator. 3.14 times 9 times 8. And we end up with 226.08 cubic centimeters. Volume is always expressed in cubic centimeters. And we get that because here we have radius squared, so that's radius times heights. So that's centimeters times centimeters times centimeters, which is centimeters to the third. Okay. Surface area and volume of a cone. Surface area of a cone is, so we're talking about the surface area of a cone is 3.14 times the radius times the slant height, and I'm just going to write that as slant. Slant height is the length of the side from the vertex to the outside of the circle. So the slant height would be, let me get a red here. Slant height would be this, the length of this side right down through there, okay, which we can see as 6. All right, 3.14 or pi times the radius times the slant height plus 3.14, the area of the base, 3.14 times the radius squared. All right, so plugging in the numbers, 3.14 times the radius, which is 3, times the slant height, which is 6, plus 3.14 times the radius squared, 3 squared. When we plug that in, 3.14 times 3 times 6, 3.14 times 3 times 6, 56.52 inches squared, plus 3.14 times, remember this turns into 9, 3 times 3, 3.14 times 9, 28.26 inches squared. So you add the two together, 28.26 plus 56.52, we end up with 84.78 square inches. So the surface area of this cone is 84.78 square inches. All right. To find the volume of this cone, the volume is equal to 3.14 times the radius squared times the height, all of that divided by 3. All right, so when we plug that in, 3.14 times 3 squared times the height. Well, now we don't, the height is the height of the pyramid. That would be this right here. So we have to use the Pythagorean theorem in order to figure out what the height is. We know what the slant height is. Slant height, remember, is 6. This is 3. We know that this is a right angle here. So remember, the Pythagorean theorem says a squared plus b squared is equal to c squared, where c is the hypotenuse, or the 6. So we have 3 squared plus b squared is equal to 6 squared. 3 squared is 9 plus b squared is equal to 36. Solve it for b. So we're going to go minus 9, cancels out. B squared is equal to 25. We're going to take the square root of it. Square root of b squared is just simply b is equal to square root of 25, which is 5. All right, so now we're back to this. So that's this value here of our height. Okay, so we have 5 divided by 3. All right. So remember, this right here is 9. All right. So we can just bring it straight down. 3.14 times 9 times 5 divided by 3. 3.14 times 9 times 5 is 141.3 divided by 3. And we end up with a volume of 47.1 cubic, remember because volume is cubic inches. All right, so that should do it for this lesson. And there's a lot of figuring and stuff, but if you take your time and you use the formulas that you're given and just plug in the numbers, you shouldn't have any problem doing this. If you have any questions, get in touch with me and let me know.